Okay, that last video I wasn't particularly happy with for a number of reasons. I need to explain something though first. When you saw the ending where I was trying to explain about you know, all of the chemistry side of this, it weren't a very good explanation, was it? But do you know what? Just lately, I've not been too well, to be honest. And the other thing is, 9 times out of 10 when I get to do these videos, I am absolutely dog tired. I spend more time in this environment than I actually do in my daytime job. You know, I work 8 hours in the day and then I come here. That's the first thing I do. So yeah, it does get a bit tiring, and at times it's very difficult for me to sort of say what I actually want to say. But getting back to that video, I'll explain a little bit more about that chemistry in a minute. Back to that video, I showed three items. Yeah, it was 3 items. Yeah, the first item was simply at that time I was working on or working with a particular carbon that I'd produced from this. You know, excuse me. So I wanted to show what the carbon was doing that I produced from that, basically. So hence that part of the video. Now, what I also do nowadays is, as well, now I've got these sheets painted on style, as I've probably explained. I cut a little square off of those sheets and I put it in the battery, and what that does is it tells me whether that battery is lacking in a certain area. Now with that carbon that we're talking about from that onion leaf, if you like, I did do that. I put a helper piece in. Now there's a series of numbers and letters on these, and it tells me what's on that sheet in respect of other carbons and the formulation. So this, if let's say I put that sheet on and it's of no help at all, I'll take it off and I'll try another piece. And if there's an improvement in what's going on, that tells me a lot. It's not the ideal situation because you're stacking up. But if there is an improvement, it's just told me that that carbon is lacking in something. Now, it could be an improvement in conductivity. It could be all manner of things, but that's generally what I do. Now, the second part, let's get to the last one, the rubbery material. I'm not going to talk about that too much because it's ongoing development. There's a long way to go, but I am getting there, and there will be future stuff on that. So back to the second one, that tiny little battery that's still sat there now. I often think to myself, well, a couple of times now, I thought, why on earth am I showing that? What is the point in showing that tiny little battery? And then I was walking out the door the other day and I looked at something. I thought, yeah, I remember now. I remember why I'm doing that. And what did I see? Well, you know, tiny batteries. I knew there was something behind it, but it just went, you know. But yeah, I mean, button cells, they're tiny, aren't they? So that's really essentially what that tiny battery is all about at the end of the day. So the video after this, by the way, I don't know if I've still got the timer. I did a run earlier on. Yes, I have. It shows that battery with a new carbon that I think I'm there with, almost. Okay, and so Something just fell. So this was the new time, with the same load, the same motor. This was the time. Okay, over 10 minutes. And this is a new carbon that I've developed, and I'm going to show this after this video. Over 10 minutes, which I'm ecstatic about. Now the carbon itself isn't perfect, there's a long way to go with it yet, but I'd say I'm 98% there with that carbon. I've structured it. I've spent months and months and months and months now working on all of these carbons, as you know. I've chucked so many away because I'm stupid and I don't document what I've got, i.e. just put it in a tub like that and just write something down, even if it's on the lid. Just write it down. Oh, that's what's in there. I've got all these carbons that I've had lying around, and one could be superb, and 3 days later I think, what was that? Don't know. So I chuck it in the bin. No more. There is no more of that now. So yeah, an upcoming video which will be a bit of an epic, I'm sorry to say. Should be interesting to some people, not to others. You know, if you're not interested, don't watch it. That's what I always say. It's a bit of an epic because it's been an epic journey, to be honest. The good, the bad and the ugly of all of these carbons, and what I did and how I produced it and all the rest of it. And what I thought at the time was going to be really, really good, but just wasn't. You know, let's say hemp. I couldn't get it to work. I just couldn't. I could not get hemp to work for me. So that's that. I don't even care what I was doing wrong now. Not now. Because I've got some other stuff really that's good enough for me at the moment. So, at the moment. So yeah. That last video, the ending, I was tired. I was really, really tired. I was worn out, to be honest. So, what did I do about that then? Well, I'll tell you what I did. I went out for a beer last night and I just forgot it all. Or I thought I did. I just had to have a relax and a blowout, you know, and that's what I did. And I've come back today. Well, it's evening at the moment. What time is it? It's 7 PM. I wasn't fresh as a daisy this morning, I must admit, but I'm okay now. So yeah, as the evening went on, I even had a game of pool. Until I looked at that 8 ball, big mistake, that black ball, number 8. My mind started wandering again, which leads me into the next bit really. Yeah, the chemistry and what we've got to learn. Now, I'm not, when I say we, I'll point this out, I'm not talking about anyone out there that's a chemist already established, or a scientist, or anyone else that's got anything to do with, you know, batteries and making batteries, designing batteries, new chemistries or whatever. I'm talking to the people now that watch my channel, let's say, and want to learn something, are interested in what I'm doing, and they're at the stage where I am, just an average Joe, having a go. Rhyming, see? So, that's all I am. So, I'm not trying to educate the educated now. I'm not trying to educate anyone, actually. I'm just trying to put some reasoning into what's going on, what I'm doing, and what we need to know, what you need to learn. And I've had to learn quite a lot just in recent times. I've had to go back to school, and I'm on the internet, and I'm learning what I need to know. And there's a lot. You know, gone are the days where you can just slap stuff together and put a drop of this and a drop of that and a drop of that, and make things happen. I mean, you can do that. You can get a piece of copper and a piece of zinc, put it in a jar or a beaker. So you've got a couple of electrodes there. What sort of a reaction are you looking for there? Well, you could, well, some zinc sulfate in solution and some, copper sulfate in solution and some zinc whatever in solution, and you've got a battery. Chemistry will happen, a redox reaction will happen, and oxidation reduction I should say, because the oxidation takes place first, doesn't it? And you've got a battery, connect up a load to it like a bulb or a motor, and the motor will spin. That's it. Instant chemistry. So with a lot of reactions we make things happen, and sometimes it just happens if you put something together. So I'm going to be doing a new video about this, and I'm going to call this new video So You Want to Make a Battery. That's what I'm going to call it, and I'm going to go into all of this properly, and a lot of the stuff that we need to know. Now, one of the first things to arm yourself with is that, which is the periodic table. Without that, I seem to have spilt something on there, but without that, you ain't going anywhere. Now, when I was playing pool, that 8 ball, it just sent my mind wandering again, and I had to stop myself and have a game of pool. I lost. I was doing well, quite well up to that point. But anyway, it reminded me of a rule, and it's what they call the octet rule, and it governs what atoms do and what they don't do with what they call the valence shell. I'm not going to go into everything. I'm just summarising, you know, what this new video is going to be all about. It's going to be about protons, electrons, atoms, ions, everything, all of that. It's all going to be in this video, and what I've learned for me to be able to get by, or to progress from where I am now. I've learned a lot already, but there's still a lot I need to know. So when you look at this periodic table, if you look on the internet, more often than not, what you find is people take this table and they remove a section, which are the transition metals, and then they take the end 2 columns and they slide it up. Now, if you look at this table, obviously there's a whole host of numbers on this table, and there's a let's take magnesium. There's a number there, 24.30 something or other, which means that you need 24 grams of magnesium ish to make 1 mole. So that's that number. There's some other numbers at the top of the column. Well, there's a number 12 next to magnesium, which happens to be my favourite metal. I've got a piece there, look, you know. Now, in its happy state, I think, quite neutral, with a no and ought, in a neutral state. Now, it's just a piece of metal at the moment, isn't it? You know, it's on that periodic table there in column 2, but they call it a 2+ metal. Why is that? Well, it is because it wants to lose 2 electrons, which is where we get back to this octet rule, the valence shell of the atom. And all of this stuff I'm going to be talking about, because it all makes sense to me now. For one, I mean that the transitional metals column, you know, they remove it because, you know, you can. It already tells a story. There's Roman numerals there, and let's take iron 3 for instance. That tells us straight away some stuff that we need to know. I'm not going to explain everything in this video. I'm trying not to, because I need to put it all in this other video. So they remove that and they push up these columns, and you've got 1, 2, and then you move along. Well, sorry, 1A, 2A, and once you've moved these up, you've got a continuation. 3, 4, 5, 6, 7 and 8A, right up to the gases, and these gases are all quite happy, and it's to do with that 8 ball, that number 8, and this valence shell, this outer shell of the atom. So all of this stuff, trust me, I'm going to be putting in this other video and explaining to, you know, us mere mortals, sorry, you other mere mortals like me, you know, not a scientist, not a chemist, not nothing. I drive, this is probably why I like things all powerful, to be honest. I drive an excavator for a living, and I just love the raw power of that thing. I've got a piece of my favourite metal sat there and I keep knocking it. Magnesium, I love the stuff, although it sounds like a broken bell, doesn't it, you know. So yeah, I've got to come up with this video. I've started to make the video, but there's such a lot to put in and cut and edit and all the rest of it, because some stuff I think, well, do they really need to know that now? But you need to arm yourself with all sorts of tables and you know, there's help along the way. It's all on the internet. I mean, oxidation states, you know, I've got a couple here. Standard reduction potentials for many common half reactions, you know, that's great if you don't want to sit there working it out. I prefer to try and work it out these days rather than look at a table if I can, and if I can't, if I get stuck, I'll go to these. What's this one? Standard reduction potentials in aqueous solutions, reduction half reaction. You know, there's all sorts of stuff out there, and it's all of help, and it's all for us to learn, and it's all stuff that I'm learning. I've got to pause the video. I'm being called, I think. Okay, sorry about that. I was being called. So where did we get to? Oh yeah, we were looking at these group numbers and stuff like that. I won't go into this anymore because it'll just really spoil that video that I want to do regarding all of this. So there's not a lot more to say really on that. There's a lot I'd like to say, but I can't because of those reasons. You know, it'll just spoil the video. So I hope that this kind of goes a little bit of a you know, somewhere along the way to explaining that last video and what all 3 items were about, and the ending where I was just, you know, washed up really, you know, worn out, dog tired, call it what you like. I feel a lot better today, and here I am. So sorry, I'm just watching my kiln as well. Yeah, this that's another point. In that video I was talking about surface areas and stuff like that, trying to explain, which I didn't do very well, again, to be honest, trying to explain the difference. I wasn't trying to mention any one in particular, like RMS, but I did, and I kind of tried to explain what was happening with the surface area that Robert produced on his piece of paper to what I actually do. Now it's not just Robert Murray Smith, is it? You know, everyone. You know, a jelly roll battery, you roll it out and there's like acres of surface area. If you take a little flat mobile phone battery, lithium ion battery, you know, it's the same thing, it's just not in a roll. They fold it over, you know. And I was trying to explain, yeah, okay, where's my piece of magnesium? That's kind of, let's say, a surface area that every man and his dog seems to produce. Like I said, RMS done that piece of paper with a painted surface area, and mine was like that, wasn't it? You know, in comparison, my surface area, a lot smaller, but same thing really. I stacked it up like that, so you know, that's the point I was trying to get across and what I was trying to explain, because what I was trying to say was if you flatten that out to what it could be, it would be a large surface area. But I seem to have found a happy medium at the moment where I don't have to spread it right out. I've brought it in a bit, you know. Now I do know for a fact that if you tried to make that, I don't know, 4 millimeters thick, 5 millimeters thick, it just wouldn't work the same. It just doesn't, and that's all there is to it. So I've found a happy medium. So I'm hoping now that I've explained that bit as well, because I didn't really explain it, did I? But back to this new carbon, which is in the next video. There it is. I'm not even going to go there with what that is at the moment, because I think it could be quite special. It's proving to be so far. I could be wrong, but I don't think I am. I've spent a long time on this, don't forget, a long time, and it has been a journey, it has been epic. So anyway, that carbon, this is some of that carbon. That's how it starts its life, and there's a lot going on in there, a lot going on. So I then have to transition that into that, which is another state, and then fire it in the kiln. And all the reasons for that will become apparent at some other later stage. So yeah, there's another video after this one then, showing that carbon in use and producing on that same battery, as I've already said, that time. Okay, 10.5 minutes under the same load conditions. I'm not going to mention now how I charged it and what, you know, what the charge rate was and all that, but it's all quite significant. But it just proves what can be done. So I know this was a bit of a boring talky one, but it needed to be said, or some of it needed to be said. Like I said, there's a lot I haven't even broached upon with this, you know, the chemistry side of it. I know for a fact that with what I know now, the information and the knowledge I've got now, with these equations, that even with the knowledge I've got, for what I want to produce in the next electrolyte, ain't going to be easy. For what I want, I know what I want. I've got a sneaky feeling that someone else that we know, well know of, I should say, has already got what I'm talking about, but I'm not certain. I could be right, I could be wrong, but I know what I want, and I do know that it's going to take a long time to achieve it, I reckon, unless it miraculously happens like that, which I don't think it will. It's going to be a long haul to produce that electrolyte that I want. So anyway, I won't bore you anymore. I'll speak to you soon.